Okay, one thing is to understand this L6, R6, M6. And L6 is going to be, you take the partition 0 to 3, and we're going to partition it into 6 equal parts. Let's see if we can do that. So 1, 2, 3, let's see, we got 1, 2, 3, 4, 5. I'm going to move over 1. I could, again, pictures aren't important, but it's enough for me to come up with some numbers over here. So, kind of looking at it, I could basically get the numbers over here. So what's the spread going to be? It's 6 equal intervals, 0 to 3, 3. 3 divided by 6 is a half. So this is going to be 1 half. This will be 1. This will be 3 halves. This will be 2. And this will be 5 halves. All right? So, to write this down, I'm not really interested in doing the arithmetic, but the arithmetic is done for you. I want to do L6. Now, each partition is equal to a half. Every single one. All I have to do is compute this thing at the left endpoints. So what's that going to be? F of 0, F of 1 half, F of 1, there's going to be 6 of them, by the way, F of 3 halves, F of 2, and F of 5 halves. All right, that's the left endpoint. What do? We pick 6 of them. Left, 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 left. 6 of them. Now, if you want to do R6, very similar, but you're taking the right endpoints. So you're not starting at 0, you're starting at a half. So F of a half plus F of 1 plus F of 3 halves plus F of 2 plus F of 5 halves plus F of 3. All right? I want to show you these things are written. I got this one written down here, and I have this one written over here. On exams, I would not expect you to do the computation. Just write it down. All right? Now, the midpoint's a little more difficult, but the partition size is still a half. All right? So let's put this down. So M6 is still a half. So 1 half. I got to do the midpoints, though. Now, what do you get? Let's talk about this thing. So the first midpoint would be 1/4. And then what do? I got to move up a half. So 1/4 plus 1 half. What's that going to give me? Well, it's 4 as a denominator, and you can get 1 plus 2, which is 3/4. By the way, they have a really nice pattern to it. And the reason for that, they're simple counting numbers at this point. Sorry about that. F of 1/4 plus F of, I said 3/4, right? And they're going to go up by 2/4. So let's put this down. F of 3 5/4. F of 7/4. Let me get my eraser out. I'm going to erase this thing on the end here because I need to continue. And we have 1, 2, 3, 4. We've got 2 more to go. F of, well, let's see, 9/4, right? And then last but not least, F of 11/4. All right, let's get our little red pen out, see if we did that. I see the half. 1/4 is 0.25. 3/4 is 0.75. 5/4 is 1.25. Let's see, 7/4 is 1.75. 9/4 is 2 1/4. And 11/4 is going to be 2 3/4 or 2.75. Looks pretty good. All right, again, I do the computation. They also said compute the actual area of this. All right, the actual area using geometry. And what I mean by that, it's really not bad to do. Let me write this down for you. And I'll look at it, and we're going to do geometry now to do it. Not by taking little partition, but using shapes that we actually know how to do. So at 0, it's 1. And then at 3, it would be, well, way up here somewhere. All right, this is the 1. Let's put this point over here. It's 3, comma. We put 3 there. What'd you get? 3, that's 12, 13, right? I'm going to divide this into 2 separate regions. And let's talk about them separately. The first region I got is this rectangle here, which is going to be 1 unit high, 3 units long. Then the next region I got is this triangle that's going to be 1 half. Its base is 3. And its height is 13 minus 1, which is 12. What do you get over here? You get 3 plus 2 goes into 12, 6. 6 times 3 is 18. You would get 21. All right, that was easy to compute. These other numbers, I'm not considering difficult. I'm really not interested in you computing those numbers on the exams, by the way. Just write it down. Thank you.